And welcome to a new series. Here in this series, I will be solving around 100 physics EMSAT questions. And this is part one, only consisting of 10 questions. So most of these questions are based, of course, on EMSAT previous exams and on physics SAT. So here we go with the question one. Which quantity is a vector? So here we have four quantities. And as you know, a vector has a magnitude and a direction. So let's discuss each of these options. So the kinetic energy, as you know, it's only a number. So we never define a direction for the kinetic energy. The same goes for the power, and the same for the speed. So for example, we say my speed is 100 kilometers per hour. I never define the direction. I only define the direction for the velocity. And most of the students have misconception between speed and velocity. So speed without a direction. What about the weight? Weight is a force, and as you know, that force is always downward. So weight is the correct answer. Question 2. A car travels with a constant non-zero acceleration along a straight line. Which graph best represents the relationship between the distance the car travels and time of travel? So that's the relationship that connects the acceleration and the distance. So it's x equal x0 plus v0t plus half at square. As you see here, it's a square. So every time there is a square in the equation, it's not linear anymore. It's not a line anymore as in this or that option. So these two options are wrong because they consist of a line. The answers should be a curve like here. Of course, it's not like a projectile. That's not the option. The correct answer is that one. We continue. Which object has the greatest inertia? As you know, inertia is associated with mass. Every time we have more mass, so it means that we have more inertia. So, which of these options have the biggest mass? Of course, the second one. Question 4. A 70 Newton block and a 35 Newton block are connected by a string as it's shown here. So we have two blocks connected to a pulley. If the pulley is massless and the surface of the table is frictionless, what's the magnitude of the acceleration of the 35 Newton block? So we need to calculate the acceleration of this block. So I'll remind you of chapter 4 in grade 11. There is one equation that describes this case where A, the acceleration is equal m2g divided by m1 plus m2. But there is a small problem here. The masses are not given. Instead, they give or they mention the forces. So we need to do a small conversion of the units. As you know, force is equal mass multiplied by gravity. So to calculate the mass is equal to the force divided by gravity. So m1 is equal f1 divided by g, and m2 equal f2 divided by g. So we just need to replace these two equations in the main one. So the new form is f2 divided by g multiplied by the gravity divided by m1, this is m1, plus m2, and that's m2. So you need to simplify the gravity in both numerator and denominator, and that's the new form, f2g divided by f1 plus f2 is 5.5. So we continue with question 5. At a certain location, the gravitational force with a magnitude of 350 newtons acts on a 70 kilogram astronaut. What is the magnitude of the gravitational field G? So it's similar to the previous question where force is equal mass multiplied by gravity. So gravity is equal force divided by the mass. So it's 350 divided by 70, and the answer is 5 Newton per kilogram. We continue with question 6. A ball of mass m is rolled down a hill with the height h. As you see here, we have a ball rolling down the hill. As it rolled down the hill, it reached a velocity v of 2 meters per second. Which of the following is true for the potential energy PE? So we need to discuss PE, which is the potential energy. When the ball is halfway down the hill, halfway means in the mid of the road. So here we have, that's the first position, and that's the second position on the halfway of the road. So here is the main height, h. Halfway of the road, of course, it's h over 2. So for the main one, it's mgh. That's the equation of the potential energy. And if we divide the height by 2, of course, we need to do the same for the potential energy. So the answer is mgh divided by 2. 7. A cyclist has a mass of 75 kilograms and his bike has a mass of 5 kilograms. He pedals along the road at 5 meters per second. Calculate the kinetic energy. So of course k is equal half mv square. That's half multiplied by the total mass of the system, which is 75 kilogram for the boy plus 5 kilogram for the bike. In total it's 80 kilogram, and the total energy in this system is 1000 joule. We are approaching the end of this part, and here is question 8. Two pieces of mud, one with a mass m moving to the right with a speed 2v, and another with mass 2m moving to the left with a speed v. When they collide and form one piece, what can be concluded about the common velocities after the collision? So here we need to remember the chapter of conservation of momentum. It's chapter 7 for grade 11. So we have two mud, they are heading to each other. So we have a first one with mass m and the other one with mass of 2m. They collide. So before the collision, we need to calculate the momentum of each one of them. So the momentum of the first one is mass multiplied by velocity. In this case, it's m multiplied by 2v. In the other case here, it's 2m multiplied by v. And as you see here in the picture, they are against each other. So of course we need to apply the minus. So it's P1, the first momentum, minus the second momentum. And the answer is 0. So the velocity after the collision will be, of course, 0. Question 9. What is the physical quantity measures the rotational effect of the force? Is it angular velocity, torque, moment of inertia, or angular velocity? So if you remember chapter 8 for grade 11, the torque, the one that they are asking for, is equal to r, the radius, multiplied by the force. So the force is associated with the torque. However, the angular velocity, of course, is associated with the v, moment of inertia associated with the mass, and angular momentum is related to the momentum itself. So torque is the quantity that's linked to the force. Question for this part. Yusuf observed a cyclist riding at constant speed around the circular track shown below. So this is the circular track of a radius of 10 meters, and decided to calculate the speed of the cyclist accurately. So we have the radius of the path taken by the cyclist. So we continue. He used his stopwatch and noted that the cyclist took 12 seconds to complete one revolution. So one revolution means one number, one complete circle in 12 seconds. And the radius of that circle is 10 meters. So we need to calculate the speed. That's what they are asking for. So as you know, distance is equal to speed multiplied by time. So speed itself is equal to distance divided by time. So speed equal distance divided by time. And what's the distance in this case? Because it's a circle, so we need to calculate the perimeter of that circle. So it's 2 multiplied by pi multiplied by the radius r divided by the time. So you apply the numbers, 2 pi multiplied by 10 divided by 12, and the answer is 5.23 meters per second. So that's it. Thank you for your attention and stay tuned for part 2.